This video is on Unit 6, Exponential and Logarithmic Functions, Chapter 13, Natural Logarithms, Lesson number 2, Log Applications, Growth and Decay. So in the first set of examples, we're going to be talking about exponential growth. Exponential growth occurs when a quantity exponentially increases over time. And there's a formula here that's given to you. F of t is equal to a times 1 plus r, and then that's raised to the t power. And each of the letters is explained to the right. So the a represents the initial amount or the beginning amount. Then you have 1 plus, and it's plus because it's growth. R is the growth rate, so that would be your percentage. And we'll talk more about percentages as we get into the examples. And then the T is going to represent time. So let's look at example number 1. Example number 1 says the original value of an investment of $1,800 is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So we're going to use this. It says that it is increasing. So that's what's going to let you know that this is your exponential growth. So F of t is equal to the initial amount is the 1,800. 1 plus the rate is 7%. So when you are using percentages in these word problems and in these formulas, you can't use 7. So what you have to do is change that percent to either a fraction or a decimal. So percent is all about 100, per 100. So you could write it as 7 over 100, or what I like to do is take my decimal, which is to the right of the 7, and move it 2 places to the left, which gives me 0.07. And if you don't understand how moving decimals works, then you can take your 7 and divide by the 100, and it will also give you the correct decimal value there. So plus 0.07. And then raised to the t. So let me go back and read this. It says, then find the value of the investment after 15 years. So we first wanted to write the equation. So I'm going to leave the t. Write an exponential function. There's the exponential function that models the situation. And then to find the value of the investment after 15 years, we're going to substitute the 15 in. This will be 1.07. to the 15th power. And then all we have to do is put that in the calculator. So 1,800 times 1.07 raised to the 15th power. And that lets me know that my $1,800 is now worth $4,966.26. And we are talking money, so please make sure that you round 2 decimal places correctly. So that's how we work exponential growth. Let's talk about exponential decay. Exponential decay occurs when a quantity exponentially decreases over time. So what you should notice about the formula is that it looks identical to the last one, except for there's a minus in between the 1 and the r, because you're going to take your 1, subtract the rate. The A is still the initial amount. The R is still the rate. Just in this case, it's a decay rate. And T is your time. So let's look at example number 4. I like example number 4. Mark bought a brand new car for $35,000 in 2008. If the car depreciates in value approximately 8% each year, write an exponential function to model the situation. Then find the value of the car in 2015. So same formula, F of t is equal to a, but in this case it's 1 minus the r Again, it's minus because it says depreciate. So you're going to have to watch the vocabulary in these word problems. Look for decrease or increase, appreciate or depreciate lets you know whether or not it's growing or decreasing, whether it's growth or decay. So we're going to plug in our numbers. The initial amount is $35,000 for that car. And then we're going to do 1 minus 8%. Again, is 8 over 100, or that would be 0.08 to the t. So there's the equation. And then for 2015, how many years is that? From 2008 to 2015. If you're not sure, you can always count on your fingers or take your 2015 minus the 2008, and that's going to tell you that's 7 years. So t is 7 there. So plugging in my 7. 1 minus 0.08 is 0.92. And then I'm going to plug in my 7. And then put that in the calculator. So 35,000 times the 0.92 to the 7th power. And I get $19,524.63. So when Mark originally bought the car for $35,000 in 2008, after 7 years, the car is only going to be worth the $19,524.63. One thing I would like to point out to you at this point is the number that is inside the parentheses. So I've highlighted that one yellow and this one yellow. And with growth, that number that is attached to the exponent is always going to be greater than 1. So with growth, this 1.07, because it's greater than 1, means growth. And then if you look at this next one, I know that we know that this is decay, but that number is less than 1, which means it's decay. Okay, so you might see questions where it's asking you, does this represent growth or does this represent decay? The hint there is whatever the number is, you got to look at the number that's attached to the exponent. And if that number is greater than 1, you got growth. If that number is less than 1, it is decay. The next thing that I want to talk to you about is something called compound interest. Compound interest occurs when interest is calculated on both the principal and the accrued interest thus far. Now, there is a lot of vocabulary that you are not familiar with here, but we will probably elaborate more on this in class. So, principal is your beginning amount. Accrued interest is the interest that you earn after a certain specified time period. And what compound interest does is your principal amount is ever changing. So let's say my interest rate compounds every month. So at the end of the first month, my principal is going to increase by the amount of interest I earn in that month. So my new principal for the second month is increased from my original principal. Very confusing, but please understand that with compound interest, your principal is earning interest, and then that interest is being added to the principal according to how you've got things set up for your time period. So let's look at this formula. It says A equals P times 1 plus R divided by N, and that inside that parentheses is being raised to the power of N times T. P is your principal or initial amount. R is still your rate or your percent. N represents the number of times that it's compounded in a year. And we're going to talk about more vocabulary here in just a second. And then T is your time. So you might see things like compounded annually. And that means one time per year. It might say quarterly. And that means 4 times per year. You might see monthly, of course, is going to mean 12 times per year. You might see weekly. There are 52 weeks in a year. Semi-annually. So semi-annually is going to mean twice per year. Can't think of anything other. There's one on here that looks like it says bi-monthly. So bi-monthly means 2 times per month. Which means 24 times per year. So you kind of have to know some vocabulary there. Let's look at a couple of examples. So example number 5 says Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So quarterly means that the number of times it's being compounded is 4 times per year. So we're going to take that formula, A is equal to P times 1 plus R divided by N raised to the N times T. And we're going to calculate how much Laura will have after 5 years. So the principal amount is the $12,000. 1 plus R, the interest rate is 8%. So 8 over 100 is going to be 0.08 or 0.08. Divided by N, which we said was 4. All of that's going to be raised to the N times the number of years, which is 5. So let's just stick all that in the calculator. Just like it looks. 12,000 times 1 plus, I'm going to pull up a fraction, 0.08 over 4, close, and that's raised to 4 times 5. So Laura's initial amount that she deposited was $12,000. After 5 years, she now has $17,831.37. Let's look at number 9. Suppose you invest $750 into an account that pays 3% interest compounded weekly. How much interest will you have earned after 20 years? So this was different than the last example because this is just asking me about interest. So the formula A equals P times 1 plus R divided by N to the NT represents the total amount, principal plus interest that you're going to have after a certain period of time. So when it asks me in example number 9 about just the interest, we're going to have to subtract to find that amount. So let's use our formula. A equals P times 1 plus R divided by N raised to the N times T. So the principal amount is $750. 1 plus the rate is 3%, which would be 0.03. Compounded weekly. So weekly is 52 times per year. So N equals 52. And then N again is 52 times the T, and that would be 20 years. So let's plug that into the calculator. So 750 times 1 plus fraction 0.03 over 52, close, and that's raised to the 52 times 20. And that gives us $1,366.35. Now, y'all, that represents the total amount. That includes that initial investment of $750. So when it says how much interest, we then have to subtract off that initial investment, and we get $616.35. Which, not a very good investment because you still haven't quite doubled your money and it's taken you 20 years to do that. So there's that. There's one other thing I would like to quickly talk to you about. This is not included in the notes, so if you'll just add this in the margin somewhere, it's called continuously compounded interest. Continuously compounded interest. So on the EOC, you might see questions where it's asking you to calculate the future amount or how much money someone would have if they invested a certain amount of money at a percent, but it's compounded continuously. So the word continuously is going to be the key word that you're going to be looking for to know that you're using this formula. And you'll hear me call this PERT. PE raised to the RT. So the future amount, A is the future amount, P is the principal amount, R is still your rate or your percent, and T is your time. But the key word would be continuously compounded. So let's say we're going to invest $10,000 at, we'll say 7% interest. Compounded continuously. I can't spell continuously. Compounded continuously for, let's say, 9 years. Okay? So what we're going to do here is we're just going to use that A equals P e to the RT. So we have A, which is my future amount. P is your principal. Times E. And that's raised to R. 7% would be 7 over 100 or 0.07 times the time, which is 9 years. So I got 10,000 times E. I'm going to use that second ln because that's going to bring me up to E, and it's got the exponent for me. I'm going to use parentheses to include my 0.07 times 9. And that lets me know that my $10,000 is now worth $18,776 and 11 cents. $18,776 and 11 cents. So that's how much money that $10,000 would be worth in 9 years in that situation. So it's a different formula representing different kind of interest. So this one's continuously compounded, whereas this is just compound interest for your A equals P times 1 plus R divided by N to the NT. So those are your notes for chapter 13, lesson number 2.